So since the water is being stored here in the bank for shorter period of time, that is why it is called bank storage. So these are the bank storage. So these are not actually the losses, but delay in the runoff process. So this is called bank storage. During the falling stage, this water generally seeps back into the stream, and then the bank storage is not actually a loss from a runoff, but a storage and delay in the runoff process. Infiltration, so the movement of water from the surface to the ground soil is known as infiltration. If this is the ground surface, normally the ground surface we represent like this, and the water moves vertically downward. So this is called infiltration, and the movement of this this water within the soil is then known as percolation. So this is percolation, and this is infiltration. So we will discuss infiltration in detail in the coming slides. Evaporation, the process by which the liquid or solid state is returned to the atmosphere, and transpiration is actually the evaporation from the leaves of the plants. So normally we have separate models available for evaporation, separate models available for transpiration, and separate model available for evapotranspiration as well. Now it depends if you are, for example, in an area where there are no chances of transpiration, you can use only evaporation model. If you are using uh, separate evaporation for the area where there is no vegetation and transpiration for another area having vegetation, so then you can use both separately. But if they are combined, so then you can use these models, transpiration. So these are this is all about the thing. Actually, these are the example that we have already discussed in the water balance, mass balance equation, inflow minus outflow equal to change in storage. So there is no need to calculate to go for. You can go through these examples for the for understanding. So this was about general about the introduction, the of abstraction. Now we will start with infiltration. Infiltration, as I have discussed, it is the downward flow of water from the land surface into the ground is known as infiltration. But since it moves with the passage of time, initially when the soil is dry, so the infiltration, the water will move quickly into the ground, and when it is partially saturated, so the movement will slow down. So that is why normally it is measured in terms of rate of infiltration, where rate of infiltration is the infiltrated water per unit time and represented by this in FT, represented by FT. The process of infiltration of water and subsequent water movement is an extremely complex process because it depends on number of variables like availability of water, slope of the infiltrating surface, then the condition of the soil, and the homogeneity or heterogeneity or other properties of the soil. So that is why it is a very complex phenomena. If the water is ponded at the surface with ample quantity mean sufficient quantity. So then in that case, the infiltration occurs at potential infiltration rate, mean the maximum rate of infiltration, the one that have it has the capacity. But if the rate of supply is less than that, or for example, there is some other parameter which are not according to the required that are feasible for infiltration, so then we will have actual rate of infiltration. So the model that we are going to discuss today, it has the problem that those are based on the potential rate of infiltration. So normally they overestimate the value. But the actual infiltration rate that can be measured by a process which we will discuss at the end of this lecture. The cumulative rate of infiltration. So if we take the integration of the this infiltration rate FT, so then we will get the cumulative rate of infiltration. Now, what is the rate of infiltration? How the rate of infiltration is being measured? So this is called infiltration curve. Infiltration, this is curve. This is the rainfall hydrograph, this one. This is the rainfall hydrograph, and this is the rate of infiltration. Initially, you see, we have the maximum rate of infiltration. This is called initial rate of infiltration, if not represented by if not. With the passage of time, the rate at which the water infiltrates into the surface, that goes on decreasing, and ultimately it reaches to the point where, for example, this is the ground surface. Initially, the water is going from the surface to the ground. So this rate at which it is going into the ground is more as compared to the water at which it is going within the soil. So that is why with the passage of time, the rate of infiltration decreases. But once the rate at which when it become saturated or partially saturated, then this movement of water into the soil become equal to the movement of water within the soil. So then we get this straight line, and this is called final rate of infiltration, represented by normally FF, or this is represented by if not. तो इनिशियल इन्फिल्ट्रेशन रेट और फाइनल इन्फिल्ट्रेशन रेट, अभी इस कर्व के अंडर जो वाटर होगा, ये दिस इज कॉल्ड इन्फिल्ट्रेटेड वाटर. अबव दैट जो है दैट इज कॉल्ड द रन अप और एक्सेस रेनफॉल, और बाकी जो है वो आपके पास रेनफॉल या रेन वाटर होगा. Infiltration is the actual rate at which the water is entering the soil at any given time. This is the Soil Conservation Services definition. Infiltration capacity, the maximum rate of infiltration. The area under the curve for any time interval represent the depth of water infiltrated. Now, area will be what? This dimension multiplied by this dimension. Now, this dimension is depth of water divided by time, and this dimension x-axis we have time. So when we multiply that, this time will be cancelled with time, and we will get only depth of water. So if you want to calculate the depth, the infiltrated water from this time to this time, so then you can calculate the area under this curve between these two limits, and that will give you the water infiltrated during that time interval. Now the downward movement is not a simple movement. Here you see the x-axis represent the increase in the water content. So as the water content goes are increasing, the depth of water infiltrated, that will also goes on increasing. But it will not be a smooth curve. It will be the curve as is shown here in the blue line. It will be like that. And with the passage of time, it will move like this here at time t1. So time is small, and available moisture content is low. So only this smaller area is being infiltrated. When the time increases, with the increase in time, the moisture content mean the rainfall also increases. So more area will be wetted. Similarly, T3, T4, and lastly T5, the final water that is being. So you can say that is the moisture profile with the passage of time during the infiltration. Now this is the curve showing the variation between the individual infiltration rate and cumulative rate of infiltration. So initially, the actual infiltration rate goes on decreasing, but the cumulative rate of infiltration will goes on increasing as is shown by the red line. Now, there are number of factors affecting the infiltration rate. Number one, the soil physical properties. Number two, vegetative cover, soil moisture condition at the time of the rainfall, rainfall intensity, and the slope of the infiltrative surface. So we will discuss them one by one. Soil physical properties. Soil physical properties are shown here in the, you can see here you can see If we move from sand to clay, so the runoff potential will goes on increasing, but the infiltration potential जो है वो इस डायरेक्शन में जो है वो इंक्रीज होगा. क्ले के लिए सबसे कम होगा, प्ले के लिए सबसे कम होगा, और सैंड के लिए जो है इन्फिल्ट्रेशन सबसे ज्यादा होगा. इसकी एग्जांपल आप यहाँ पे देख लें. अगर फॉर एग्जांपल हम ये हमारे पास जो है वो टाइम है, लेट्स से 120 मिनट्स का टाइम है, 120 मिनट का टाइम है, और मैं कम्युलेटिव इन्फिल्ट्रेशन अगर आप क्ले के लिए ले लें, तो क्ले के लिए जो है दैट इज ऑलमोस्ट 20 मिलीमीटर कम्युलेटिव रेट ऑफ इन्फिल्ट्रेशन. लेकिन अगर इतना ही टाइम में जो है सैंडी लोम के लिए लो, सैंड के लिए, तो दैट इज ऑलमोस्ट 250 या 260 मिलीमीटर. तो ये जो है ये फर्क है सॉइल फिजिकल प्रॉपर्टीज की वजह से, कि वो रेट ऑफ इन्फिल्ट्रेशन जो है वो कितना जो है वो ज्यादा होता है, जिसकी पोरोसिटी जो है वो ज्यादा होती है. फिर वेजिटेटिव कवर. तो वेजिटेटिव कवर जो है मैंने आपको वो रेनफॉल इंटेंसिटी जो रन अप हमने कैलकुलेट कर रहे थे उसमें भी आपको मैंने बताया था. वेजिटेटिव कवर जो है दैट विल टेंड टू increase the rate of infiltration. There are two reasons. Number one, for example, this is the soil surface, and these are the soil particles. If there is no vegetation, so the water will fall from the atmosphere over the bare soil directly, which will have certain energy, and that energy may break these particles into pieces. और जब ये particle इसको pieces में divide करेगा, so there are chances that it may block these pores, partially or fully, but it may block these pores. Sorry, just a minute. So it may block these pores. For example, these are soil particles. So when it is break into particle, it may block some portion of the pores. So when the pores are blocked, which is the way of entering water into the soil surface, so the rate of infiltration here that will go on decreasing. Now instead of that, if there is vegetation, for example here, if there is vegetation, so now the water will not directly fall over the soil, rather it will fall over the vegetation and then will slowly fall onto the soil particle. So it will not be capable of breaking those particles uh, with that intensity as in case of bare soil. So the pores will be intact and the rate of infiltration जो है, that will be more. One reason is that. The second reason is if the water is flowing in this direction, for example, the runoff is flowing on the surface and there is vegetation. So what will happen that this vegetation will actually hold this water, will retain this water for some time, will abstract this water for some time. तो जब इसको abstract करेगा, तो the pores जो है it will get time to infiltrate water into the soil and the rate of infiltration will be more. But if there is no vegetation, if there is no vegetation, so in that case, then there will be no obstruction. So when there is no obstruction, there will be no infiltration or less infiltration. So that is why the increase in the vegetative cover जो है, that will increase the rate of infiltration. Rainfall intensity, it behaves like the same as vegetative cover. If the rainfall intensity is low, so it will not have certain more energy. So then breaking of the particle will be lesser and it will result in lesser breakage and more infiltration. And if the intensity is more, so there will be more breakage, more blockage of the soil pores and less infiltration will take place. Antecedent soil moisture condition. So if, for example, you have initially dry soil, if you can look into the figure, so initially the rate of infiltration will be very high and then it will go down decreasing. But if initially moist soil, so then there will be low infiltration rate. Ultimately, the capacity The final infiltration rate for both cases will be the same because the soil will have constant capacity. So the antecedent soil water content also alters the infiltration rate. Generally, a wet soil has a lower infiltration rate than the dry one. Or slope of infiltrating surface, तो it is obvious if the slope is more steeper slope है तो पानी जो है वो तेजी के साथ जाएगा तो इन्फिल्ट्रेशन के लिए टाइम जो है वो कम होगा और अगर आपके पास फ्लैटर स्लोप होगा तो इन्फिल्ट्रेशन जो है वो ज्यादा होगा तो यहाँ पे मेन जो चीज़ है दैट इज द इन्फिल्ट्रेशन अपॉर्चुनिटी टाइम तो जो भी फैक्टर आप डिस्कस करें उसमें देखें कि आया उसके लिए जो है दैट इज प्रोवाइडिंग मोर इन्फिल्ट्रेशन अपॉर्चुनिटी टाइम और लेसर इन्फिल्ट्रेशन अपॉर्चुनिटी टाइम अगर लेसर होगा तो इन्फिल्ट्रेशन रेट भी लेस होगा अगर ज्यादा होगा तो इन्फिल्ट्रेशन रेट भी ज्यादा होगा Richard equation. Now we will discuss some models which will be used for calculation of infiltration. एक होता है calculation of infiltration, एक होता है measurement of infiltration. Measurement of infiltration के लिए मैं आपको आखिर में एक जो है मेथड जो है वो बताऊंगा लेकिन यहाँ पे calculation of infiltration सबसे जो complicated और सबसे जो जो है मतलब बेहतरीन और एक्यूरेट जो इक्वेशन अभी तक जो अवेलेबल है वो है रिचर्ड्स इक्वेशन तो ये हमारे पास जो है जिस तरह हाइड्रोलिक्स में हमारे पास जो है सेंट विनेंट इक्वेशन है इसी तरह ग्राउंड वाटर के लिए हमारे पास जो है वो रिचर्ड्स इक्वेशन जो है वो अवेलेबल है लेकिन ये इसका सोल्यूशन जो है दैट इज नॉट सिंपल दैट इज वेरी डिफिकल्ट इसका सोल्यूशन और वो क्यों वो अभी हम इसको डिस्कस करेंगे कि व्हाई इट इज डिफिकल्ट लुक इनटू दिस इक्वेशन इट इज अ नॉन लीनियर सेकंड ऑर्डर पार्शियल डिफरेंशियल इक्वेशन तो लीनियर सिंपल होते हैं ये नॉन लीनियर है ऑर्डिनरी डिफरेंशियल नॉर्मली इजी होते हैं ये पार्शियल डिफरेंशियल है क्योंकि पार्शियल डिफरेंशियल जो है वहाँ पे यूज होता है जहाँ पे एक फिनोमेना जो है जो आप डिस्कस कर रहे हैं वो बाकी वेरिएबल पे भी डिपेंड करता है तो जब आपके पास एक सिंपल फिनोमेना हो और एक जो है वो